Let's start with Herbart, Weber, and Fechner. Johann Herbart was a German psychologist who was one of the first to give it its own name. What he studied wasn't quite philosophy, but it wasn't quite physiology. He is also known as the founder of scientific pedagogy, which is the study of the science of teaching. In 1824, he published his book, and I wanted to include the title because it explains how he looked at psychology: experience, metaphysics, and mathematics. He tried to explain psychology using math and physics and his training in those areas. In his book, he wrote about his belief that we learn by observing and thinking about our environment, about the external objects in our environment. He called these external objects reals. This lecture, this video that you're watching, it is something in your external environment. In order to learn something about that object, you have to pay attention to it and think about it. He also believed ideas compete to be in our conscious. Those ideas that you are currently aware of, those ideas that you are currently thinking about, make up what he called the apperceiving mass. Sometimes ideas that are not part of the apperceiving mass compete and make their way into it. If your cell phone rings, if you get a text message, if you get an email, the presence of that stimulus will now take your attention away from the video and lead you to focus on something else. In that moment, the cell phone is part of your apperceiving mass, and the video that is no longer part of the mass. He believed that these ideas could be represented by different strengths, and these strengths, these different levels of intensity, can be described in mathematical terms. In the early 1800s, Ernst Weber was also active. He was a physician and conducted a variety of experiments in an effort to understand sensation and perception. He studied tactile sensitivity by mapping the sensitivity of different parts of our skin. He was interested in determining the point at which two different points on the skin are noticed, the point at which we can tell that there are 2 points instead of one. What he found was sensitive skin has a lower threshold than less sensitive skin. The most sensitive parts of your protective layer require a smaller distance between 2 points than the tougher, less sensitive areas of your skin. So take a look at the 3 images that I have here on the slide. On the tongue, 2 points only have to be 1 millimeter apart for you to be able to determine, oh, yep, that's 2 needles, not 1. On the fingertip, the 2 points, the 2 needle pricks, and they weren't meant to hurt, but the 2 needle pricks have to be about 4 millimeters apart for you to recognize that there's a difference. There's 2 different points instead of 1. On the shoulder, it has to be anywhere between 35 to 75 millimeters. So there's quite a bit of a difference between your tongue, your fingertip, and your shoulder. Your tongue is going to be the more sensitive organ compared to your shoulder. He also looked at how much a stimulus must change in order for you to recognize a change, for you to see the change, hear the change, feel the change. For instance, how much heavier must a weight be for a person to notice that the weight is heavier? The amount of weight that is required for you to perceive a difference, that amount is called the just noticeable difference. The difference at which you are just able to determine there is a difference. Gustav was a German philosopher and a physicist. He is known as a pioneer in experimental psychology because he founded psychophysics, the study of the relationship between stimuli and sensation. So for instance, a light in the room. Fechner was interested in how your eyes perceive that light, how changes in that light impact your perception, and the different thresholds at which those changes must reach in order for you to perceive the difference. So Fechner, who was one of Weber's students, he took Weber's ideas about the just noticeable difference and he tested them. So let me explain a little bit more about this idea of stimulus change, and then I'll show you an example. True to his physicist roots, Fechner developed a law. He called it Weber's law as a tribute to his mentor. This law says that as the intensity of a stimulus changes, think about a light bulb or a noise. As the intensity of the stimulus changes, a greater difference between it and the comparison stimulus is needed in order for individuals to perceive a change. Let me show you an example to explain. Do these two boxes have the same number of dots? Don't count the number of dots and don't think too much about it. Do these two boxes have the same number of dots? Again, don't think too much about it and answer quickly. The difference between the two boxes on the left is 10. The difference between the two boxes on the right is also 10. But most people take a few milliseconds longer to judge the second set on the right. When there are just a few dots, it is easy for us to pick up on that 10 dot difference. We can see it easily. When there are many more dots, a 10 dot difference is not enough. It requires a 20 dot difference, a 30 dot difference before we can perceive a difference between the two groups. So the first set of boxes has low intensity. The second set of boxes has high intensity. Weber's law says that as that intensity increases, a difference between the original stimulus and the new stimulus, that difference needs to be greater. Thus, a 10 dot difference is just not enough with the boxes with more dots. Here's another example. One weightlifter bench presses 50 pounds and notices the addition of 5 pounds. A second weightlifter who bench presses 500 pounds does not recognize the addition of the 5 pounds. It would require 20, 30, 40 additional pounds before the second weightlifter would likely recognize, oh, this is heavier.